Alright, so the final thing I want to go over here is how to write a loop, how to write loops in assembly here. So let's look at this loop here. I've written it in Java code, and right here I've given you an integer n. Let's remember that this integer n can be anything, any integer that's less than 255. And why I say 255, because that's how many bytes, or it needs to be an 8-bit number, and the highest 8-bit number you can get is 255. So let's keep that n is any number less than 255. And I've also given a sum here, so what we're going to be doing in this loop is having a running sum of the first n numbers. In this case it's 20, so the first 20 numbers. So the way I've set up this loop is I've actually started I at n, so I is equal to this number, and then what I'm doing here is decrementing I until I does not equal 0. Or as long as I does not equal 0, sorry. You'll see in a second why I've done this, but basically what this loop is going to do is start at I is equal to 20. It's gonna do sum is equal to sum plus 20. So right now the first number that's going to be in there is 20. The sum is first going to be equal to 20 because it started off at 0. Now it's going to do I is equal to 19, and it's going to do sum is equal to sum plus 19. And that's going to be 39 because it's adding 20 to 19. And it's just going to keep on going until I equals 0, and that's when it stops. Okay, so why did I make the loop as I did? Because normally you would make a loop, say something like this. If you wanted to count the first 20 numbers, you would do something like int I is equal to 0, then you would say I is less than or equal to n, and then you would increment like this, and then you would finish off your loop. Well, why didn't we do it like this? Well, that's because HC12 assembly actually comes with some really nice looping features, and there are a set of instructions that basically just let you loop through, as if it was a for loop for as long as you need it to, so as long until this condition is met. So let's go over those instructions right now. So the first one I want to look at is the BBAny instruction. The BBAny instruction is written with a counter beside it, as well as a relative offset, which is basically just a label. So what does this do? Well, this decrements a counter, so it goes counter minus minus as long as the counter does not equal 0. Yep. And every time it decrements, so counter goes down by 1, and it will also branch or jump straight back to the relative offset we have here. So say our counter was register B, and our instruction was, our relative offset was called next, and then every time we loop through, we want to add accumulator A, or something with the number 7. Let's say that's what our loop does, and now we want to decrement decrement our counter B and jump to next every time. So it's going to keep on going through this loop until it's going to the first counter, it's going to add 7 to accumulator A. It's going to decrement B, and then it's going to jump straight back to next until B equals 0. That's just how it is. There's also a alternate option, which is just the opposite of it, basically. It's called TBEQ, and it does basically the same thing, but it decrements when it is equal to 0. So instead of decrementing whenever it's not equal to 0, it does it when it's equal to 0. Okay, so the next instruction is BBAny. And based off this first letter, you might be able to guess that all this does is it increments the counter as long as the counter is not equal to 0. I'll just write it like this for time's sake. And this also takes a counter and a relative offset. This also does have a TBEQ instruction, and it does the exact same thing as this one, except it increments it. Alright, and the final instruction here is the TBEQ instruction. And this also takes a counter and a relative offset. And basically, all it does is checks if the counter is equal to 0. And that's all it tests just for that. That's all it is. And there's also TBEny, which tests the count for when the counter is not equal to 0. Okay, so based off these instructions, I think you can now see why I've made this for loop in such a funky way. Because right here, I'm saying as long as I does not equal to stop this loop when I is equal to 0. So let's try writing out this loop in our assembly language. Okay, so first thing I'm going to do is declare n. So n, I'm going to make it a symbol, and the symbol does not actually get stored in memory, so we can write it before any of our org statements. So I'm going to say n is a symbol that has a value of 20. Okay, now I'm going to org 800 memory location, and I'm going to declare my sum variable. So what I'm going to do for that is reserve a memory word of 2. Why am I doing word? Because later we're going to use a register X to count our sum. Okay, so now let's org 4000. And now we're going to start writing the actual code for the loop. Okay, so first what we need to do is load our counter. So I'm going to load accumulator B, and you can use any of the registers except for PC. So you can use A, B, D, X, Y, or the stack pointer as your counter, but you just can't use PC for it. So I'm going to use accumulator B, and I'm going to load into there the number 0, because sorry, not the number 0, we're going to load into there n, because we're starting at the number n. So let's do that, and now I'm going to load into register X the number 0. Why? Because we're going to use this to count our sum. So this is our sum counter, pretty much. Okay, so now we need a label to return our loop. So how are we gonna do that? So we're just gonna call it loop, our label, and now we can write out the code for the actual addition in the loop. So first instruction I'm going to use is ABX, and all this does is adds the number in B to the number in X. So that's exactly what we're doing here. We're adding sum, which is in X, or sorry, we're adding I, which is equivalent to B in our assembly code, to sum, which is equivalent to X in our assembly code. So first instruction was ABX. Now I'm going to use the DBNE instruction with our register B and our loop. And so now every time we go through this, it's going to add B to X, and it's going to decrement B and return to loop. It does this until b is equal to 0. Cool? So now after we've looped through this multiple times, we need to be able to store our actual sum from x into our variable, which we saved here for sum. So very easy instruction right here. I'm going to store x into sum. And now we need to actually quit our program. So I'm going to put a quit label here. Sorry, I'll put that lower down. Quit. And right here we end our program. And logically this should go straight into quit, but it might be good practice to branch to our quit label so that we guarantee that it goes there. Cool? So yeah, there you go. That's exactly how you make a loop in assembly, and I hope that was a good, helpful video for you. Thanks for watching.